Alright, so right now we are going to compute the indefinite integral of x squared times arctan 6x. So right now, let's take a look at the integral and see which one of our integration tools we can use. So if we make a substitution for x squared or 6x, we're going to either get an x out of that or a 6 out of that. And neither of those are going to help us very much because it doesn't get rid of all the x's into a different variable that we can substitute. But we do see that we have two functions that are multiplied to each other. So that means that this is an ideal candidate for integration by parts. So let's consider which one to differentiate. Now, usually we differentiate the function that is easier to differentiate, or the one that is able to become more simplified. But in this case, if we do that, then what we're going to have to end up doing is find the integral of arctan 6x, which I don't think is going to make things any easier. So instead of doing that, let's differentiate arctan 6x, and we'll take the integral of x squared. So dv is going to equal x squared dx. If we differentiate arctan, then we get 1 over 6x squared plus 1 times 6 dx. So this is from the chain rule, and this is just from the derivative of arctan 6x. So if we find v, then that's going to be 1 over 3 x cubed. And according to our integration by parts formula, which tells us that the integral of u dv equals uv minus the integral of v du, we can simplify our integral here to this. So we're going to do uv, which is 1 over 3rd x cubed, times arctan of 6x minus the integral of v du. So that's the integral of v, which is 1/3 x cubed, times du, which is 6 dx over 6x squared plus 1. So right now, we need to find this integral, which seems a little bit more simple than the integral up there. So we're going to have to simplify this and solve it. So I'm just going to circle what we're going to simplify. So this part out here, this negative sign still exists, but right now all we have to worry about is this inner integral. So what this is going to simplify into is the integral of, the numerator becomes 2x cubed, the denominator becomes 6x squared plus 1, and this is with respect to x. So now if we take a look at this, we can see some interesting things. We can actually now use substitution. If you haven't seen it just from looking at this, well, we can split this apart. So we have 2x times x squared dx on the numerator. And on the denominator, we have 6x squared plus 1. So what we can do here is we can substitute a variable for x squared, because if we differentiate that, we get a 2x dx. So let's give that a try. So since we used u and v already, we'll try to use something else. So we'll let w equal x squared. So dw is going to equal 2x dx. So as you can see, this simplifies our integral by a lot. So in the numerator, we have x squared equals w, and 2x dx equal to dw. And in our denominator, what we have here is, so this is actually supposed to be 6 squared, so this is 36. Okay. So right now in our denominator we have 36x squared plus 1, which simplifies to 36w squared plus 1. So let's write that, 36w squared plus 1. Or 36w plus 1. That's what I meant to write. There we go. 36w plus 1. So now what we can do is we can try to solve this easier integral. So let's try another substitution. So if we're going to do that, we can circle this, and we are going to try to solve this. So we're just going to go up over here. We have the integral of w over 36w plus 1 dw. So if we let another variable, w, let's call it x. So let's have x represent 36w plus 1. So then dx is going to be 1 over, or dx is just going to be the derivative of x with respect to w. So there's not going to be any 1 over. It's going to be 36 dw. So we have dx equals 36 dw. So right now let's solve for w. So what does w equal? W equals x minus 1 over 36. So that's just rearranging this upper equation over here. And right now, what does dw equal? Or dw, well, that equals dx over 36. So now we can simplify our original integral to the integral of the numerator, which is w, but here we've written it in terms of x, so this is the numerator. And the denominator, we've also written that in terms of x. So the denominator is x. And we've also written dw in terms of dx. So dw is going to be dx over 36. So essentially what we have here, if we rewrite this to something that's a little more simple, we have 1 over 36 squared, because there's 1/36 that comes from here, and 1 of the 36s that come from there. So 1 over 36 squared times x minus 1 over x dx, which is just equal to 1 over 36 squared, the integral of 1 minus 1 over x dx. And what we can do now is we can do this integral fairly easily. So what we are going to get is 1 over 36 squared, and the antiderivative of 1 is just x, and the antiderivative of 1 over x is going to be ln x. And don't forget our plus c. So we have this. So we have this, which is in terms of x. And we have this, and we can substitute that into here. This can be substituted up into this pink section. I believe I used this pink. Nope, that's the wrong pink. And this can be all substituted back into our original equation, or our original integral that we're trying to compute. So let me just section out a small area here where we can write our answer. We're going to write our answer as 1 over 3 x cubed arctan of 6x minus this pink stuff. So this pink stuff is this blue stuff, which is this blue stuff over here. So we're going to minus 1 over 36 squared, and that's going to be multiplied by x. So what is x? X is 36w plus 1. Well, what is w? W is x squared. So what we're going to get here instead of x is equal to 36w squared plus 1. Or 36x squared plus 1, excuse me. So that is our x. So then we're going to subtract from that ln x. So ln of x, which is 36 x squared plus 1. I did not realize this, but we actually used the x variable twice, which is very, very confusing. Okay, just pretend that these x variables on the right are some other variable. Okay, so our final answer should be 1/3 x cubed arctan of 6x minus 1 over 36 squared times 36x squared plus 1 minus ln of 36x squared plus 1 plus c. So in here we're actually subtracting it, but our c is just any constant. It doesn't really matter. It's a constant of integration.